empirical formula. Empirical formula of a compound represents the simplest whole number. Take down. It represents the simplest whole number, right? It is the simplest whole number. And as a ratio of various atoms present in one molecule of the compound. Got it? In one molecule of the given compound. Let me explain. You know the molecular formula of glucose. Do you know? C6H12O6, right? C6H12O6. Now, this is the molecular formula. Okay. The empirical formula is the simplest ratio. What is the simplest ratio of a CHO? CH2O. I hope now you should be able to understand this, right? So, what is empirical formula? This is the simplified or simplest whole number ratio. Okay. So, whole number ratio of the elements present in a given compound. Okay. So, what are the elements present in glucose? Carbon, hydrogen, and oxygen. Okay. Right. Now, let us proceed. So, there are some steps to determine the empirical formula. Okay. Take down. Now, I think I can explain based on a problem. Okay. Take down. An organic substance. An organic substance containing an organic substance containing carbon, hydrogen, oxygen gave the percentage composition as carbon is equal to 40.687%, hydrogen 5.085%, and they have given additional parameter, that is some data, that is called vapor density. So the vapor density of the compound is 59. Now we are supposed to find out the empirical formula followed by molecular formula of the given organic compound. Got it? Right. Now, what you are supposed to do is you have to draw a table. Put element in the first column and put its percentage weight. Then, what is the atomic mass of that particular element? And then you can mention the number of moles of that element, because this is the percentage weight, this is atomic mass. Therefore, weight by atomic mass is equal to what? That is the mole, is it not? So the relative number of moles. Then you have to arrive at the simplest ratio. Simplest ratio. And in the final column, you have to arrive at the simplest ratio, whole number ratio. the simplest whole number molar ratio. This is the simplest molar ratio. This is the simplest whole number molar ratio. Means you will get some ratio. You choose the lowest ratio, and based on that, you have to arrive at the molar ratio. Okay, I will explain one by one. Now, what are the elements present here? Carbon, hydrogen, oxygen. So, what is the percentage of carbon here? 40.687. What about hydrogen? 5.085. And oxygen is not given. So what you are supposed to do, you can add these two because ultimately you will get 100, right? Subtract from 0. So add this 7 plus 5, 12, balance 1, 9, how much? 7, once again 17, is it not? And then 7, then 45. Am I right? Please check once again. 7 plus 5, 12, balance 1, 9, 8, 7, balance 1, 1 plus 6, 7, and 45. Now, what you are supposed to do, you have to subtract this to find out the amount of oxygen. The remaining is oxygen, is it not? So, 10 minus 2, 8, 9 minus 7, 2, 9 minus 7, 2, 9 minus 5, 4, and then 9 minus 4, 5. So you have got 54 point, how much? 228 of oxygen. So you need not expect all the elements to be given in the formula, I mean in the problem. Rather, you can find out by making the difference. Okay. So after all, this is the remaining quantity from 100. So 100 minus, add these two, and you will get the oxygen percentage. Now, what is the atomic mass of carbon? 12. Hydrogen? 1. Oxygen? 16. Done. Now, what you're supposed to do, you have to arrive at the moles. We know already weight by molecular weight. Is it not? So, what is the weight here? 40.687 divided by 12. Now, similarly, 5.085 divided by 1. Okay. Similarly, 54.228 divided by 16. Now tell me the value. 3.39. Okay. Then 5.085. That's good. Then 3.389. Right? 389. Okay. Now you identify the least ratio. Which is the least ratio here? 3.389. Okay, so you have to divide by this. Okay, you take this and divide each. Okay, so 3.390 divided by 3.389. It is roughly equal to 1. Is it not? 389 means almost 90. So 1. What about this? 5.085 divided by 3.389. How much? How much? Work out. Use calculator. 1.5. Right? Yes. And what about this 3.389 divided by 3.8? That also yields 118. Is it not? So 1. Now you have to convert this as what? Simplified or simplest whole number molar ratio. Right? So for which what you can do, you can multiply entirely by 2. Right? So that you can have the simplest whole number. Because in a ratio, you should not get any decimal. Do you understand this? So we want to have whole number ratio only. So in that case, 2 into 1, 2, 2 into 1.5, 3, 2 into 1, again 2. Therefore, carbon should be 2, hydrogen should be 3, oxygen should be 2. This is the empirical formula. So this is the way we are determining the empirical formula. Got this point? Okay. Huh? Yeah, finally. So we have got this empirical formula. And what is molecular formula? There is a relationship between empirical formula and molecular formula. Okay. So the empirical formula, you've got certain weight. What is the weight of empirical formula weight? What is that? C into, that is 2 into 12, right? Plus 3 into 1. Okay. Plus 2 into 16. What is that? Tell me the empirical formula. 59. Very good. So 59. So what is the empirical formula weight? It is 59. Okay. So this is an important formula. I mean, important empirical formula we have derived. Now we have one important relation, that is molar mass, that is represented as M, is equal to, or you can call it molar weight, molecular weight is equal to 2 into vapor density. What is that? 2 into vapor density. This is a very important formula. So from this, we can find out the molecular mass of the given organic compound. Do you understand? Therefore, molecular form weight is equal to, what is that? We have got the vapor density. So 2 into, what is the vapor density given here? 59, right? It is given. Therefore, that is equal to 118. So from this, it is pretty clear that the molecular mass of the given organic compound is 118 gram per mole. Do you understand this? So now we have got the molar mass. Okay. Now, once again, we can do. We have got the empirical formula weight, how much? 59. Okay. Are you able to follow? So from this, now it is clear that take down N, that is the molecular formula is equal to N, that is the ratio into empirical formula. Okay, empirical formula. Similarly, the molar mass is equal to N into empirical formula weight. Done. So from this we can find out N. So N is equal to M divided by empirical formula weight. So what is M? M is here 118 that we have already found out. Divided by, what is the empirical formula weight? The empirical formula weight is 59. So you can put 59. So 2. Now we can adopt this formula, that is molecular formula is equal to N into empirical formula, right? Therefore, molecular formula is equal to, what is N? 2 into, what is the empirical formula? The empirical formula we arrived at C2H3O2, right? C2H3O2, okay? Now you can multiply this. Therefore, we are able to get C4H6O4. So this is the molecular formula we have worked out. Got this? Okay. So the molecular formula of the given organic compound based on the percentage of carbon, hydrogen, and oxygen is found to be C4H6O4. So, in order to verify your answer, you can work out the molecular weight of this one, right? So, what is the molecular weight of this one? You have got C4, that is 4 into 12, and H6, 6 into 1, and O4, 4 into 16. How much? 64, 6, this much, 48. So 70, that is 118. So this is the molar mass of the given compound, and that was obtained from the what? This formula, 2 into vapor density. So our answer is perfect. Okay. So this is a very interesting uh, study in determining the empirical formula, and based on the percentage of carbon, hydrogen, and oxygen. Sometimes they give oxygen percentage, sometimes they may not give. In that case, you can take the remaining value. Okay. So likewise, you should be able to calculate the empirical formula mass, molecular formula mass, and the empirical weight, then molecular weight, etc., based on the given inputs. So this is a very, very important concept in this topic, that is basic concepts in chemistry, right? So I will try to give you some worksheet, try to solve all those problems, okay? And if there is any doubt, you can ask me.